Good morning. My coffee's finished. Wish there was more, but no. Let's continue talking about UFO UAP star drives. Okay, what are the possible theoretical underpinnings of some of the behaviors that are reported, alleged, and recorded? Because they all fall in different categories that occasionally overlap. Now, I talked about the proton drive, and the proton drive that I described sounds like something that would be very destructive to not only anything around it, but also the ship itself. It sounds more like a death ray, and any object made of matter, especially these UFO UAPs, do not appear to have external ports, jets sticking out of it, windows, anything like that that's been reported so far. It would cause degradation of that matter. So I don't think that's what's driving them, assuming it's real. And we can't assume they're real, we can't assume they're not real. We just know that there's a body of evidence that we can examine. And we can test hypotheses if we ever get a hold of some of this stuff, okay, assuming it exists. So let's talk about a neutrino drive. What is a neutrino? We need to back the hell up, and this goes beyond simple public school, high school physics. This is a bit more advanced, but a neutrino is a particle that we began to theorize about that is a particle, but it travels at the speed of light. But it's not light, it's not a photon, and it's not a form of other radiation. I think other forms of radiation that are particles travel just below the speed of light. And the way the neutrinos accomplish this is that, unlike a neutron, which is probably the most massive of the atomic particles, and has weight, this has almost no mass, yet somehow we found a way to detect it. Now, neutrinos are interesting because they can literally pass through thousands of miles of rock unaffected. They're very small. They can slide between the spaces of atomic particles and maybe even subatomic particles. I'm not sure about that, but definitely between the spaces of atoms, right? And so, a very elusive particle, and we have neutrino detectors. I saw a picture in a magazine a long time ago. One neutrino detector was filled with liquid, and I've even heard of, liquid gas and things like that, and it's a process I don't understand, but I know it exists because we can verify their existence. We can note their passing, and they're predicted by theories that have high predictive value. So, for example, the theory of gravity, people are like, it's always interesting hearing anti-science people. Often religious fanatics say something like, well, that's if you believe in the theory of evolution, and they think if they just say theory that invalidates something, that it's untrue, it's purely speculative. Folks, gravity is still just a theory, but it's highly predictive. We can predict escape velocities and maximal accelerations and air resistance. We can use a lot of these theories to land something on the moon to within about a meter, okay, and Mars and so on and so forth. We can figure out how much fuel we need to get in the air and how big a parachute we need to not die when we parachute down. Very important and very accurate stuff. So, the theories that we use to calculate the existence and postulate the existence of a neutrino helped us verify their existence and other things, not just the neutrino theory. All right? So the idea is, if you have matter and antimatter, and instead of letting them react in a chamber, okay, you push them out in a stream so that, I guess, the streams intersect. Would the beams have to point this way, or would they be parallel? If they're parallel, I can only assume that the stuff on the inner side interacts and the stuff on the outer doesn't right away, but then the stuff on the inner side of the beam or projection begins to explode and project outwards and spread that reaction. So again, this isn't something we have, and we don't have the current technology to do, but according to York Dobyns, who gave the presentation at an SSE talk that I saw online, a recording of one, and it wasn't dated, so I can't tell you when it was given. This produces a reaction that produces mostly energy and neutrinos, or all energy and neutrinos. Although, again, maybe between the theory and the practice, if there was another form of radiation produced, it would be detectable. And the idea is, if you had superconductors that I think he said were 20 times more effective than the best superconductor we have, it could be possible to take all of that energy produced and redirect it. I think he said it would produce photons, which are energy, that's light, and photons produce heat, and the light and the heat would then be redirected perfectly to power the device, and the only thing emitted would be neutrinos, which again, in theory, you could point a neutrino beam at me and beam right through me and not hurt me. Although, again, since neutrinos do interact with matter sometimes in some way, conceivably it could have an effect on me. Could be deleterious instead of beneficial, right? So, again, we are dealing with some unknowns and some theoretical constructs, but if the neutrinos are leaving at the speed of light with high energy, then a controlled neutrino beam could be used as reaction mass. Now, I'm no physicist, okay, but you still have to solve some mechanical problems. So we have a sphere or a cube, all right, and normally the way reaction drives like jets, propellers, rockets work is something goes out this end and the thrust produced drives it this way. And if you want to change direction and you have no medium, now if you're traveling in air, you have wings and tails and you adjust the ailerons and the wind gives you resistance. But if you're in the vacuum of space, you don't have resistance. Or if you're a cube in a sphere in the atmosphere, you don't have control surfaces, you don't have wings and tails, so you're not guided by friction. You would have to have other neutrino drives built to the sides. Now, I've seen this device on a rocket, so I'm going to actually draw one for you, okay? So I've seen this on the sides of rockets, and these are called attitude jets. And so you have a rocket, and this is not to scale, it would be very small, they would be bulging out of the side of the rocket. You have attitude jets, and usually on each side, and sometimes other attitude jets strategically placed. Now, where I've put a dot, that's little miniature rockets firing, right? So you notice at the center of each angle, these dots represent little miniature jets poking out of the side of this rocket, right? And so I've got the main exhaust giving out jet fuel this way, and if I want to start moving to the right, this one starts firing and exerts force, and the combination of this jet and that jet starts to turn it, right? If I wanted to make it go away from you, this jet would begin to fire, and that would cause it to turn. If I wanted to bring it towards you, the jet on the other side would fire. If I'm going in this direction, this jet begins to fire and provides counterforce and could decelerate, so on and so forth. All right. Now, you would have to have not just a main neutrino drive, but neutrino attitude jets, and they would have to be inside the vehicle because, again, thus far, no one's seeing evidence of attitude jets, just as no one is seeing evidence of wings and tails and other things like that. The only other option is if you had only one neutrino drive inside of this thing, it would have to be capable of making rotations. Now, the fact that the objects are seen progressing and they make these abrupt turns, but they maintain that forward momentum means, well, they would have to have more than one drive. So we need to differentiate here in this theoretical construct that you have the power source, which is a matter-antimatter reaction, and then you have the propulsion, which is neutrino. I don't know how a neutrino particle that has so little mass, I don't know how much thrust that would generate. And you physicists out there, you need to probably delve into this idea. It is fringe science, but again, there are some very brilliant, bright physicists, York Dobyns being one of them, saying this is a theoretical possibility. We just don't have the engineering capacity to build it right now, but it could be built given that capacity. And again, a spacefaring civilization that's thousands or millions of years more advanced than us in technology maybe could do it. So that's a possibility. It would mean that they're still bound by the speed of light, and the biggest technical problem in this is containment, because you hear about these things crashing, right? And if they had a matter antimatter engine, the antimatter is the problem. Antimatter reacts violently upon contact with matter, and 100% of the antimatter and 100% of the matter is turned into energy in the form of an explosion. The idea was if you beam them in the same direction, instead of an omnidirectional explosion that's hard to contain, you have a controlled titrated explosion, and it only produces neutrinos and light. And again, I'm not sure why only neutrinos and light. That's beyond my knowledge and ability. So, again, I think the main purpose of this speculation is it might explain a possible mechanism for what appear to be impossible aerial maneuvers and behaviors that just don't seem possible under our current understanding of physics. My only issue is if you're emitting neutrinos and light, I wonder how perfect can any superconductor and energy conservation method could be made, because if it's anything less than perfect, it would show up in infrared, and sometimes when these objects are flying, they're actually cooler than the ambient temperature around them, right? And one way, if it wasn't perfect, maybe if we improved our infrared, maybe we could detect a thermal beam or infrared beam emitting from these things as they maneuver. The other one is if you study where the maneuvers are being detected and you study the directional changes and elevation changes, then you would see, well, does the back end of this beam, does the opposite direction of their movement correspond to any known neutrino detector? And then you would look to see if there was a surge in neutrino detection, and that would maybe confirm the presence of a neutrino drive. Very different from a neutron drive, right? We don't know enough about neutrinos to know what would happen if you had a tightly packed beam of them, a stream of them. Could there be any negative effects? Or are we looking at a really fantastic new way to drive sublight speeds? Just something to think about, folks. Have a wonderful day.